All right, Mr. Bear here again. Just trying to shoot off a couple examples at you, help you out a little bit in terms of solving these equations. We're with quadratic equations. We're trying to figure out what our solutions would be. So next example I got above me, again, another one from your notes on the back side. 9w squared plus 66w plus 21 is equal to 0. We know it's a quadratic, biggest exponent here is 2. We know it's a trinomial, especially because we already have the equation equal to 0, which we're really excited about. Not a lot of work to handle up front with that before we get going with this process of factoring, which we always start off with the GCF. So we have 9w squared, 66w, 21. We think to ourselves, coefficient-wise, is there a number that divides evenly into 9? 66 and 21 there is, which is the number 3. So I do have a GCF here. GCF, numerically speaking, is 3. We'll take a look quickly at the variables. I have a w squared, a w. The constant on the back end kind of ruins that for us, but we do have a 3 that we can pull out of this, and we're going to divide 3 from all those terms. So there goes the 3. 9w squared divided by 3 would be 3w squared. I got 66w divided by 3, that's going to be 22w. And then 21 divided by 3 would be 7. GCF factored out, fantastic for us. 3w squared plus 22w plus 7. Inside the parentheses, quadratic trinomial. It does not look like intercept form for quite yet. Excuse me. So I certainly have more to be done in terms of the factoring, or at least taking a look at the factoring. So I'm going to look inside the parentheses here. My A value, B value, and C value based off of the basic standard form that we had from the last unit. Go ahead and label my A, B, and C. AC being 21, 3 times 7. B value, of course, is 22 inside the parenthesis. So we need two numbers that would be able to multiply the 21 and add the 22. Not a lot of options with multiplying the 21. 21 and 1, of course, negative 1 and negative 21. But hopefully 7 and 3 would go through your mind potentially. But with the fact that we have to add the 22 really limits us. And we hopefully understand that those two numbers would be 1 and 21. 1 times 21 is 21. 1 plus 21 is 22. So those are the two numbers. Those two numbers are going to be replacing, or helping me replace this 22w for the linear term. So I have 4 terms now, and I'll be able to do my factor by grouping. So let's go ahead and write this out again. 3w squared, this 22w that we had before, that's getting replaced. I'm going to put 21w. I'm going to put 1w. I'm going to do plus 7. By the way, no, it would not matter. No one asked me this the other day. If I flip-flop those terms, doesn't matter. If I put the 1w first or the 21w first, does not matter in this problem. What does matter is I have 4 terms in here now, so I can go ahead and do my factor by grouping. I'm going to try to see for each binomial if I could go ahead and get a GCF. So the first binomial I'm taking a look at is up front here, 3w squared, 21w. GCF for that would be 3w, and I'm left with a w plus 7. If I do this correctly, I should have w plus 7 inside the parentheses again when I do it to the second binomial. 1w plus 7, no GCF there, but I do need a placeholder. So I'm going to put plus 1 down. And that does provide me with the w plus 7 that would match up for my common binomial. When I finish up this factor by grouping, I need that common binomial, in this case w plus 7. And then I'm also going to have a binomial made up of the GCFs. And adding those terms, 3w plus 1 would be that binomial. Now it looks like it's in intercept form. Of course, we started with something that looked like it was in standard form. We had to pull a GCF out, and it was 3. And now we see not only intercept form, but we see kind of some of the intercept forms that we were taking a look at previously in the last unit. So we're still going to go ahead and apply the zero product property here to see what would our solutions be to this equation when set equal to 0. Now, of course, one of our factors is 3, and technically all of our factors go through the zero product property rule. But we all know 3 is not equal to 0. There's not a variable to solve for here. So I'm going to go ahead and just kind of forget that the GCF was out there in the front in terms of solving the equation. Of course, I would need that 3 for many reasons in graphing. W plus 7 is next. And I think we should be clear with that. W is equal to -7. That would be one of our solutions for this problem. And then finally, 3W plus 1. We'll set that equal to 0. And a little bit more work. But I would get W is equal to -1/3. Of course, a solution, of W is equal to -0.3 repeating would be perfectly fine. But either way, I have two solutions here for this equation. W is equal to -7. W is also equal to -1/3. We did all our work, took this thing from being a quadratic in standard form all the way down to the intercept form, and that made it a lot easier for us to solve this equation.